For problem number 5, we have y equals the natural log of the natural log of x. Now, there's no way for us to expand this or simplify it in any way, shape, or form because ln x, this ln x right here, it can't be split apart. It's not a product. It's not natural log times x. It's natural log of x. So we're going to go right into finding our derivative, where this right here is going to be the u. And this is where things might get a little bit confusing, so follow along carefully here. So our derivative, dy dx, keep in mind you could also be writing that that's y prime if you prefer. That notation's okay. So this is the outside, and then we have the ln x underlined in blue is the inside. So the derivative of the green circled ln is 1 over the inside ln times the derivative of ln, which is 1 over x, okay? Let me see if I can color code that a little bit better for you, okay? So let's say this ln x is the same as this ln x right here. And this 1 over x, that's the derivative of this ln x right here, okay? So we've got a log of a log. So the green circled log becomes this right here, the 1 over the inside, and then the derivative of the inside is 1 over x. So then how do we write our final answer here? And that's something you need to be very, very careful about. So I want this answer, dy dx, or y prime equals the x and the x in the denominator, those cannot be combined. This is going to be written as 1 over x natural log of x. It is not the same as 1 over the natural log of x squared, okay? This is a big fat no for this problem, okay? The x on the outside cannot be combined with the x on the inside. It's kind of like when we were doing trig functions. Whatever was inside of the trig stayed the same at all times, and that's going to be true here once we've done our derivative. We can't merge something outside of a log with something inside of a log. Okay, so that's problem number 5. For problem number 6, we're going to do a little comparison. We're going to do 2 problems in one. All right. So problem number 6 should look somewhat familiar to you. We've seen things like this where it was, say, for example, x squared minus 3 to the 5th power. All right, and if you see something like that, that should trigger in your mind, that's a chain rule problem, okay? So this is going to be a straightforward chain rule, all right, where the ln of x is the inside, and the parentheses to the 5th is the outside. So the question is, how do we do the derivative of parentheses to the 5th? So here we're going to have f prime of x is equal to 5 parentheses to the 4th times the inside of the parentheses stays in ln x, and then the derivative of the inside, the derivative of ln x, is 1 over x. So this derivative, f prime of x, comes out to 5 parentheses natural log of x to the 4th all over x, okay? So that's a chain rule where we can't avoid doing the power rule version of a chain rule, okay? There's no property of a log that allows us to rewrite that one because the 5 applies not only to the inside but to the outside, the natural log as well. So there's no way to rewrite it. We have to do chain rule, okay? But on this second problem, we can rewrite this because when we have just f of x equals natural log of x to the 5th, we can insert our own parentheses right here, and it's the same thing. So this could be done in one of 2 ways. If we go straight into the derivative, we could say that f prime of x here is 1 over the inside, x to the 5th, times the derivative of x to the 5th, which is 5x to the 4th, and that will reduce down to just 5 over x, because the x to the 4th and the x to the 5th will reduce down to just an x in the denominator, okay? So that's the first way you could do that problem. Or You could rewrite the original function using properties of logs. You can pull this exponent out in front before doing anything else. And then for that derivative, we could say that it was f prime of x is equal to 5 times the derivative of ln x is 1 over x. So again, we're getting to a final answer of f prime of x is equal to 5 over x. Okay? So that's the answer for the second one. Now you can see the answers for the very first part, the work done in red, are completely different from the answers for the work done in blue and green, okay? So it's very important that you pay careful attention to your parentheses and the location of exponents. If an exponent is inside of a log, you can pull it out in front before doing a derivative using properties of logs. If it's outside of the parentheses, meaning outside of the logarithm, then we can't move it and we have to do chain rule, okay? And that's the end of problem number 6.